Welcome to the Trend Detection Podcast, powered by Siemens.
Hello and welcome to Trend Detection. We are back with Johnathan Bonner for another episode of our mini-series, Predictive Maintenance Unmasked. In this series, we're going to be covering a different vertical each episode and how predictive maintenance helps navigate the industrial challenges that arise in each one. So in this episode, we'll be talking about navigating the challenges that arise in the automotive industry. So welcome, Johnathan. Thank you for joining us again. How are you?
Good, thanks. Thank you for having me.
Thank you so much for joining us today. So I guess to start off on this topic, would you be able to provide some insight on Senseye Predictive Maintenance's experience in the automotive industry?
Yeah, absolutely. Senseye has got quite a history with the automotive industry. In fact, our very first massive client or big client is an automotive manufacturer. So extensively, Senseye's DNA was born through automotive. A lot of our learnings, especially in the early years, have come from automotive. We have, of course, moved on from there. We are applicable in all industries, on all asset types in every region of the world. But within the automotive industry specifically, we are monitoring over 100 different asset types, different operations. And then over, I'd say, tens of thousands of assets are being monitored from automotive factories around the world currently by Senseye. So quite an extensive history, as well as huge amounts of success that we see year on year.
Thank you, Jonathan. That's a really good intro and kind of a good oversight on Senseye PDM's experience within that industry. So in terms of unexpected downtime, it'd be great if you could kind of shed your knowledge on how does unexpected downtime impact the automotive industry and what are the associated costs?
Well, in the automotive sector specifically, the cost of downtime is huge, and we're looking at millions of dollars, pounds, euros per hour. So the cost associated with unplanned downtime is high, or any downtime event, whether it's planned, proactive, or unplanned. So really, for an automotive factory, any stoppage to production has huge impact. So especially also if you look at their process, it is very linear. It starts off, let's say, with sheet metal stamping and pressing, and at the end of the process comes out a car ready for testing. But everything runs in a series. Bits get added on to the entire car vehicle manufacturing, each step by step, until you have your finished product. So if any stoppage along that way or along that process, although there may be buffer points, has an impact. And the longer you have a stop for, the more effect it has down the stream in your production. So one event within your exhaust plant, for example, one downtime event within the exhaust plant can have huge impact on the assembly or the final assembly, just depending on how long that event is. So a simple downtime event within one factory can have huge consequence in the rest of them down the stream.
That's really interesting, thank you. So honing in on kind of the perspective of unexpected downtime, would you be able to kind of shed some light on how does predictive maintenance directly prevent unexpected downtime?
Well, predictive maintenance effectively is an evolution from traditional condition monitoring, but a lot of that process is now automated. The process of data collection, analysis, and reporting is automated. So really what you receive when you start a predictive maintenance project or initiative is early indication of asset degradation. It will give you early insight that a part or component of a machine is degrading, and you should have good indication of what is degrading and what you should do from there. But a predictive maintenance solution evolves over time. It becomes more capable. The more interaction, the more feedback, the more history, the more maintenance events it can learn from, the better it can be at telling you what the problem is. So for an automotive factory, they would have initially early indication of asset degradation. This means that they can plan in the repair when it best suits production, long before the asset actually fails and breaks and causes a whole bunch of damage. So they can plan this in, they can make sure they have the correct spares, They can make sure they have the correct resource and people, and they could possibly do the repair when it best suits production. So you can still finish making a run of cars, vehicles, but you plan it in when it best suits the production. Maybe when your buffer stock, your buffer stores are nice and full, so you have a bit of time, you can do a small repair now without actually affecting production overall. That's really to do with your unexpected, your unplanned downtime events, but also having a centralized visibility of an entire plant's production of assets, of their condition, is vital, because you can really then start to plan in the best maintenance throughout the entire plant. You can really see what assets require maintenance, and more importantly, which assets don't. Because your planned maintenance actions or events still take time, they still affect production. So if you have better visibility of what does need maintenance, and more importantly, what doesn't need maintenance, you can really have a truly effective maintenance strategy throughout the plant.
That's great. Thanks, Jonathan. It'd be really great to hear your perspective from a product kind of quality perspective. So how would you say that predictive maintenance contributes to maintaining or improving product quality in the automotive industry?
Well, with better reliability will come better quality. It's just a fact. Assets, when they're degrading, they're not performing in the best possible way. So an asset that is currently degrading may not have the highest quality, or may not be giving the best quality output that it should. This could be small drifts, small tolerance drifts, or this could just be flat out faulty components that you're now manufacturing, putting together. So with a higher reliability, higher asset reliability, your quality does improve. Absolutely.
Yeah, again, that's a super insightful answer. Thank you, Jonathan. So, kind of honing in on a cost perspective, it'd be great to hear your insight on how does implement predictive maintenance affect the overall operational costs in, the automotive sector, as well as considering the linear process. So yeah, if you could kind of shed your thoughts on that, that'd be great.
Yeah. So speaking specifically around the operational costs, everything that makes an automotive plant run costs a huge amount of money. The amount of electricity they're using is huge. The amount of people and resource required to run an automotive factory is huge. The amount of services, heating and cooling and compressed air and a full range of utilities provided to the plant has huge costs. So if you have a section that is not producing, you're effectively not making money. However, those costs around power, heating and cooling, around people are still there. You're still paying for those operational costs, but you're not producing. So that's where those costs of downtime are exceptionally high with an automotive. It's the loss of product and production, but also the maintenance of your costs, your operating costs, to keep everything there for a moment when you do start production again. So having predictive maintenance, having that centralized visibility of an entire plant's condition, entire factory's condition, being able to plan in your maintenance actions when it best suits you, when you have the right resources, when it best suits production and so on, means that you have more uptime. You are producing more of the time. You have better OEE. And for our clients, we do have a significant increase in OEE throughout all of our clients, never mind just the automotive sector. So predictive maintenance means that you can, in those times, be producing more and therefore keeping your operational costs at bay as much as possible.
That's great, thank you. So moving on to systems and solutions, what systems or solutions would you say that automotive companies can use to effectively collect, process and utilize data for successful predictive maintenance?
Well, the automotive industry is actually extremely automated. They have huge amounts of automation, which actually means they have huge amounts of relevant data already existing on site. So if we could get access to if we could make that existing data available without having to introduce any new hardware or solutions to gather and process and load that data, then that's rapid value. What was the question again?
It was
Yeah,
it was what systems or solutions can
yeah,
automotive companies use to effectively collect, process, and utilize data for successful predictive maintenance?
yeah. Okay, so the existing data is already there. They have the automation, the infrastructure typically is already existing. So if the automotive site has the correct people resource, OT engineers who can make data available from their automation layer, IT staff who can then make that data available from site to the cloud, that's rapid value. That is immediate effect. However, there are also many other systems and solutions that could be implemented at a relatively low cost and high value. This is around taking in multiple OEM providers of automation, whoever they may be, being able to communicate with their automation systems, unify that data in a centralized point and push that to the cloud. That is also an option that we implement quite often for our clients. It's really around trying to utilize what they have existing on site before investigating any additional hardware. But if there is need for that additional hardware, additional systems, that could be done at a relatively low cost and rapidly gaining value for the client.
Thank you, Jonathan. So I think it'd be good to kind of move on to the people aspect of the automotive industry. So, would you say that there is a skills gap in the automotive industry, concerning the implementation? I want to ask that again. So, stop that again. Thank you for your insight on that, Jonathan. So moving on to the people aspect of the automotive industry, would you say that there is a skills gap in the automotive industry concerning the implementation and management of predictive maintenance solutions?
No, I would say all the skills and resources required for any digitization project, including predictive maintenance, exists within automotive, in automotive factories in the automotive sector. The amount of skilled workers required in maintenance, in production, in planning, in every aspect of the automotive industry is so high that the skills are already there, the people are already there. I would say one of the challenges we face is not around having the skills available from the site. It's actually around getting the time dedicated from these people because they are very much busy doing their day-to-day functions, their day-to-day roles. But if we can get enough time from each individual in a project team, we don't battle with skills at all.
No, again, that's a great answer. Thank you. As you said, I think, yeah, it's definitely just making sure that, all the key people are educated on the benefits and what this can do, for the company. So yeah, again, that's super insightful information. So thank you. So moving on to the topic of kind of resistance, which is something that can be quite common in companies that are new to taking on predictive maintenance. So it'd be great to hear your advice on how should automotive companies address resistance or skepticism towards adopting predictive maintenance practices from both management and floor staff, as it can appear in different areas of the business.
Yeah. I guess resistance to new technologies is universal. People are resistant to change naturally. So really, it's around involving the key stakeholders from the very beginning in a project. It's around education and making sure that everyone involved understands what the outcome is. And the outcome of a predictive maintenance implementation is not to reduce jobs, it's to drive efficiency. So with our experience in automotive, in one of the body shops, they had a reliability engineering team who were there. Each member of that team were responsible for tens of assets, critical to production, but they were responsible for maintaining the asset reliability and condition. With Senseye, instead of now monitoring tens of assets or being responsible for tens of assets, these reliability engineers were able to be in charge of hundreds. So it's really the outcome is driving efficiency. So as soon as people know that, as soon as the project teams you're engaging with understand that it's not about job replacement, it's about driving efficiencies, making them the heroes of the company, because their areas of responsibility are well maintained, well looked after. They're addressing things before it's a problem. They're not having a firefight, and you're not having these huge costly downtime events. That then makes them feel more comfortable. But inevitably, whether it's management, whether it's ground floor, shop floor workers, you really need to target the value for the individual. So for management, the value of the project is going to be around financial gain, return of investment. So that for them is what you need to try and satisfy to help with the skepticism that they may have, or the reluctance. Is this going to bring a return of investment? Does my initial investment make sense? Does it make sense for me to invest people's time, effort, skills on the project? So that is very much around the financial benefits. Whereas from the shop floor, it is around day-to-day functionality. Is this going to make them more efficient? Does this fit in with their daily workflows? Is this easy to understand? Is this going to become a new job and take over a huge portion of their concentration? Or does it fit and integrate seamlessly within their workflows? So really, there's a number of aspects we consider, but we address them early on, as I said, by getting them involved as early as possible in the project. Because at the end of the day, we don't want a solution that just gets thrust upon people and now they have to take on an extra body of work. We want them to be involved from the very beginning, so it's their solution, so that they feel a part of the journey from the beginning. It includes their inputs, and they have a hand in the project when it really flourishes at the end.
Thank you, Jonathan. I can imagine that information will be reassuring to a lot of listeners. So moving on to kind of the scalability aspect of things, how would you say that automotive companies can ensure that their predictive maintenance solutions are adaptable and scalable as they expand?
Really, any predictive maintenance solution that you want to implement at scale has to be applicable on all asset types. So there are approaches on the market which rely on pre-built machine learning models for a specific asset type, or a company will come in and customize machine learning algorithms for a specific use case. This, first of all, takes huge amounts of effort and huge amounts of resource and time and huge data sets. And it's a very iterative process until you have something that's workable and good. Whereas if I speak about Senseye specifically, we have an approach which applies on all assets of any age, anywhere around the world. And it's about defining normal and then building on abnormal, or at least notifying from abnormal and building on that understanding at least. So when it comes to scalability, you want to select something that can be applied on any asset, that isn't going to take up huge amounts of time, that doesn't require data scientists from their end or as a client from your end. Something that you can put on any asset, regardless of its production, regardless of where it is in the world, that will fit in with your existing infrastructure.
Again, thank you, Jonathan. That was a super insightful and helpful answer, and again, just providing reassurance to current and prospective clients as well. So just wrapping up the episode with our final question and kind of taking a look into the future. How would you say that automotive companies can future-proof their predictive maintenance solutions against technological obsolescence with rapid advancements?
Yeah, I would say that predictive maintenance is just one strand, one facet of digitization. And so many companies globally have got digitization initiatives, whether that's on energy management, OEE, inventory tracking, predictive maintenance. So when you are assessing what you're wanting to do, even if it is or specifically around predictive maintenance, think about what it is you'll want to do in the realm of digitization in the future. And then say, am I doing something now in my current initiative? Am I doing something now that will enable my future initiatives? Or am I doing this in isolation? Am I going to have to invest individually in predictive maintenance, in OEE tracking and monitoring, in energy management? And really, the most scalable approach, or the best approach in any industry for any company, is to implement this strand of digitization and be able to utilize those same layers of infrastructure, architecture, resource, hardware, whatever you're investing in, and that should enable your other initiatives ongoing. So that is how I would recommend companies future-proof.
Again, that is great advice. Thank you so much for joining us today, Johnathan. That wraps up our episode. So thank you, listeners, for tuning in. Thank you, Johnathan, for joining us as always. And we'll be back again very soon with another episode. Thank you and goodbye.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.